Hello, welcome to Code with Richard. And in this episode, I'm going to walk through my solution to LeetCode problem number 26, remove duplicates from sorted array. And here I copy and pasted the description of the problem from LeetCode. Given a sorted array of nums, remove the duplicates in place such that each element appears only once and returns the new length. Do not allocate extra space for another array. You must do this by modifying the input array in place with big O of 1 extra memory. All right, so I'm going to start talking about my strategy for this one and some notes. So as the hint suggests, we need to do an in-place single traversal. I mean, I suppose we could traverse multiple times, but we're going to do it in one. There's some state that I'm going to maintain. So one is a most recent. As we traverse through this list, we need to know what the most recent element is. And I decided to keep it as a variable. However, you could just keep another pointer to the array and use that instead, just to look back to a previous element as you traverse, but I decided to use a variable. I decided to use a single index pointer to what I called my current element. And I'm going to remove my duplicate element in place. In this array, I'll just delete it. And I'm also going to have a counter that I'm going to increment. So increment a counter when see a new unique number. And this is the value of this counter is what we can remove at the end of our traversal. Okay, so let's jump into some examples. So example number one, let's just say our input nums is just a simple list with 1, 1, and 2. So in here, we expect our output to be equal to 2 because there's two unique numbers. And at the end of our traversal, nums is just going to be the list of 1 and 2. And then the one of the extra ones is going to be. And so at the start of this, my counter that I'm going to maintain, so this one that I'm going to increment when I see a new unique number, is going to start off at 0 because I haven't seen anything yet. My input nums, very simple, it's just 1, 1, 2. And what I'm going to do is I'm going to grab my first element as my most recent. So this first element in this list, I'm going to keep it as my most recent. And then also, I'm going to increment counter and pointer. Okay. So what is this going to look like? I'll perform a call to another function, and my counter is going to be 1 because I've seen one unique number, which is my most recent, which is number 1. And then my nums, what is that going to equal? It's 1, 1, and 2. And when I say increment my counter, my pointer, well, my pointer initially is going to point to my first element. And so I'm going to increment it and just point it to my second element right here. And in this iteration, we can compare the most recent, what we saw, to the element at this pointer. And in this case, we found a duplicate and we want to remove it. And also, we're going to perform an in-place deletion. So we're going to delete the element and we're going to keep our pointer. And go here and just copy. Copy our pointer and our number. This is what we saw before. And so see, how does this work? We're going to delete our element and keep our pointer. So if we delete this element right here, we can see that the rest of the list slides back into place. So this pointer pointing to the second element at index 1 is going to point to the next element in our list, and we've just deleted the duplicate. And then we do another comparison. We look at the number, we're at our current pointer and our most recent, and it's different. So we found a new number. And all we're going to do here is we're going to increment our counter and pointer again. So actually, let me just go to copy and paste all of this. And make sure that our pointer is pointing to the right spot. Let's delete these for a second. So from this step to the next step, we're going to increment our counter. C equals 2. We found 2 unique elements. Well, we also have to update our most recent in this case. So we'll put update most recent. And when we update our pointer, we point to the end of the list. And in this case, since our pointer is going to the end of the list, we are done. So we can return 2, which is our expected output. And then now our nums is just this list 1 and 2, which is what we expect. Okay, so let's go on to another example, which is a little bit more complex. And in this one, let's say our nums has duplicate 2's in the middle of it instead of just at the front. And we'll see that this algorithm works as well. So what we'd expect is our output is going to be 3, and nums when we're done is 1, 2, and 3, with the duplicate 2 being removed. So we're going to start off with a counter equals 0. Our input nums is just our input array. And similar to what we did before, we're going to follow the same algorithm. We're going to grab the first element as most recent. And then we're going to increment counter and we increment our counter as 1. Our most recent element is 1. And our nums just equals the same array right here. I'm sorry, excuse me, list. And because we increment our pointer, it's going to go to the next element of the list. Here we found a new number. And we can increment counter and get. So let's copy and paste. All right. So we increment our counter, which is 2. We found a new most recent, which is 2. And now for this pointer, which used to point to this 2, we're going to increment it to the next element. And so in this case, we found a dupe. We want to remove it. Excuse me, it. And in this case, we're going to delete element and keep the pointer. So we'll just copy and paste these as well. So we delete an element and keep pointer. We don't do anything to this counter. We keep it the same. The most recent is going to be the same. We're going to delete this node number 2, keep the pointer the same way. So now you can see is another example the pointer is still pointing to the same element in this list. So we found a new number. And again, oops, found a new number. And again, we increment counter and pointer. So we'll copy and paste these as well. When we increment our counter and our pointer, our count goes to 3, our most recent goes to 3, and our pointer goes to the end of the list. Remember, when our pointer goes to the end of the list, we are done. And you can see here our count is 3, which is what we expect, and the expected output numbers 1, 2, 3 is what we have. And just to round things out, I'm going to put another example 3, just so we can see what happens if our input nums is an empty list. Our output is going to be 0, and our nums is just going to be an empty list. And we can see that similar to this, the ending case is when our starting pointer points to no, when there's no element here, we're just done, and we return the output, and we don't modify nums. And that's what we have right here. Okay, so let's go down to implementation. We have this class solution, and it gives us remove duplicates. And the first thing I'm going to put in here is the base case. So what if nums, the length is 0? Well, we can just check for that. If this is 0, we'll just return 0 because that's what our output is. We don't even have to create a counter. Else, we need to do something, and the way that I implemented this counter is actually not in an explicit variable, but I just am using a recursive function. So I'm going to add 1 to my return type. So whenever we want to increment our counter, when we find a new number, we're just going to add 1 to the return type. And I created another function to call. I'm just going to pass in the original nums. I'm going to pass in the most recent, which is going to be nums of 0, and I'm going to pass in the next index in my list. Remember, the very first thing we do is we grab the first element as the most recent, and we increment counter and the pointer. So this one, adding 1 to the return is incrementing our counter. Incrementing our pointer is just passing in a 1 because we first start off by looking at the first element, and our first element is right here, which is our most recent. That alludes to the helper function, remove dupes. And the first thing we're going to pass in is just nums, which is the list of int, which is basically the same nums that we pass into this first function. I'm going to call my most recent, which is also an int, and I'm going to call my counter a position. And that's just a position as an index into my nums array. And this is going to return an int. And now let's see what. So as a base case, we need to check our position. Remember, this position is an index into nums. So we can say is position greater than or equal to my length of my nums, in which case we're out of bounds. We don't need to make any modifications. We can return 0. Remember, 0, the return type is this counter that I'm incrementing whenever I see a new unique number. Otherwise, I can look into the next element into my list. And I need to check to see if it's the same as my most recent or not. So remember, in the case that this will be if my position now points to the second 2, I need to check to my most recent to see are they equal or not. If they're equal, then I can remove it. If they're not equal, I can keep it. So I can do a check. If my most recent equals the next element that I'm looking at, its position, then I found a duplicate and I want to remove it. Remember, what I do when I want to remove it, I'm just going to delete the number at this position. Oops. Let's put this here. And then I want to recurse. and then position stays the same. As you remember before, the position stays the same because if we delete the element at some index, the rest of the list will slide in place. So this same position will point to the next element in the list. So I'm going to call myself recursively. And remember, I don't have to add anything because I saw a duplicate. There's nothing to add. Pass in the same function, sorry, same list nums. My most recent stays the same because I found a duplicate. And remember, I pass in the same position that I saw before. So now I want to create an else clause. So the first one is I found a duplicate because my most recent equals to my number. And in this case, I found a new number. And so I'm going to return 1. So I'm incrementing my counter, which is really just my return, because I found a new number, and I'm returning the sum of all my unique numbers. So I found a new one. So 1 plus call myself. Always going to call nums. And then what is my most recent? My most recent now is this, my current number that I'm looking at. Now this position. And I need to increment my index into my list, which is this position, +1. Okay, so now that my implementation is done, I can run some unit tests. So I created a unit test file. And what this is my input numbers. This is what the output number should look like after I'm done. And 5 is the number of unique elements. So in this case, no elements are removed. The second case, a bunch of these 1s are removed, and then we're left with the same output as the first array. And then there's just a couple different cases that I decided to test. And if we go ahead and run it over here, now we can see that all of our tests run. So thank you so much for joining this episode of Code with Richard. If you have any questions, please leave them in the comments, and hope to see you at the future episode. Thanks.